This is Physics 5, January 2006, and it's question 4. To investigate the structure of the atom, Rutherford, Geiger and Marsden directed a beam of alpha particles at a very thin gold foil. They found that the particles were scattered at angles varying from 0 degrees to 180 degrees with respect to the direction of the incident beam. Practically all the particles had a zero angle of scattering. That is, they went straight through the foil, but a very few came straight back. That is, the scattering angle was 180 degrees. State the conclusion made from the fact that practically all the alpha particles had a zero angle of scattering, and the conclusion is that the atom is mostly made up of empty space. And then state two conclusions made from the fact that very few alpha particles had a scattering angle of 180 degrees. Now, 180 degrees indicates repulsion. And so, therefore, the first thing that you can say there about the 180 degrees is that the nucleus was positively charged. And the reason you know that is because it repelled positive alpha particles. The second thing is the fact that very few of them were repelled, and that means that, again, the nucleus was really tiny. Or very small, or only occupied a tiny proportion of the space. Right, the next part of the question. Another way of probing matter is to fire a beam of electrons at a very thin film, for example, a carbon graphite film. Determine the scattering pattern observed in this case. Illustrate your answer with a sketch. Now, you know that if you have if you have a beam of electrons diffracted in this way, you'll end up with a circular pattern like that. And the circles depend on the angle of scattering. And so there's the pattern. If you have a beam coming through a material, I'll draw the material in a minute, then you're going to have, depending on the angles, you're going to have the pattern at the edges of the circles. And then there's the atoms in the material that your beam of electrons is coming through. So there's a beam of electrons going through there and being scattered at different angles. So if we even marked in one of these, I might mark in a different colour so you can see it. See there's your angle of scattering. Now, if you said ring of diffraction pattern, and you labelled this angle of scattering, and you labelled this lattice, carbon lattice, and beam of electrons, then you have shown that you've got 2 marks for that without even really having to say anything. Maybe it's a good idea to mention that at different angles you get a different ring. And that ring is, of course, a place of constructive interference. State the property displayed by the electrons that is responsible for this type of scattering pattern. There's a number of answers they wouldn't have minded. This is a property belonging to waves, so it's a wave-like property. You could have said that this shows wave-particle duality. Or wave diffraction. So all those things, this is a property which belongs to waves, even though electrons are actually particles. Rutherford's experiment was carried out in an evacuated tube. The electron scattering experiment must also be performed in a vacuum. Explain why the vacuum is essential, and the reason is to avoid deflection of the electrons by air because they cause ionisation and then they lose their energy. And if that happens, you won't see the pattern.